Gopi sir, ready sir? Good afternoon, ma'am. Am I audible? Okay, sir.
Good afternoon, sir.
Good afternoon, ma'am. We'll start the session now, ma'am. Another 1 minute.
Okay, sir. Okay.
A warm welcome to everyone gathered here on behalf of Funimala Institute of Technology, Department of Electronics and Communication Engineering. We welcome all the participants once again for the AICT sponsored Sttp. It's indeed my great privilege to introduce our beloved speaker to the August gathering. Dr. S. Venkata currently serves as a professor, computer science and engineering at Sri Krishna College of Engineering and Technology, Coimbatore. She has received a doctorate degree from Manonmaniyam Sundarnath University in 2018 in the Department of Computer Science and Engineering. She has an experience of around 20 years in teaching and published journals in peer-reviewed journals, and also she has published several books chapters, as well as she has got applied for several patents as well. Our area of interest includes artificial intelligence, image processing, network security, and information retrieval. She is a member of IEEE Computer Society and Computer Society of India. She has organized a number of conferences, workshops, staff development programs, and seminars. She shines in her various responsibilities such as NAC coordinator, NBA coordinator, and entrepreneurship cell coordinator. She was a smart worker who managed time efficiently, examined a problem from all the perspectives, and arrived at best solutions. Multidisciplinary approach, the ability to work both interdependently and in terms of alignment to update context, and mental alertness, all shown through her efforts. It's indeed my great privilege to have you here, ma'am. I hand over this session to Dr. S. Venkata. Thank you, ma'am.
Thank you. Thank you, sir, for the warm welcome. Thank you. So, shall we wait or we can start with the session?
We'll start the session.
Okay, sir. Thank you. Okay. So, thank you so much, Saran, sir, for the invite. Okay, good afternoon to one and all present here. He has given an introduction about me, so nothing more about that. And straight away, we'll get into the topic. So the topic here is what we are going to discuss is about machine vision effects in AI and its challenges. Am I audible?
Yes,
Am I
ma'am.
audible,
You're
sir?
audible,
Okay.
and presentation is also clear. You can go ahead, ma'am.
Okay, sir. Okay, sir. Thank you. Okay, machine vision. So, since FTP was happening for too much of time, so you might have, by this time you might be knowing what is machine vision and everything. So, how it is related to AI and what are the challenges in AI that we are going to see now. So, machine vision actually it is a guide of automated process and quality improvements. So, automated association AIA, imaging association, they encompasses all the industrial and non-industrial applications with a combination of hardware and software. So that there comes the machine vision with the software applications. So software applications means they have taken AI as a now AI is a booming thing. So they have taken AI as one application, and they have implemented different algorithms or techniques with AI with machine vision. So it provides an operational guidance to devices in the execution of their functions and capture the processing of images. With the processing of images, how this applications will continue. So that is what this machine vision is. So what is the relation between the machine vision and AI? So machine vision is the ability of a computer to see how it employs one or more video cameras, analog to digital converters, or some digital signal processing, and how this can be implemented together, and how the resulting data goes to the computer by a controller. So that is what is machine vision and the AI relation. So machine vision is actually similar in complexity to voice organization. So when you think about machine vision, so you may be getting a word of computer vision. So we may be thinking whether computer vision and machine vision both are same. Actually, there is a slight difference between the computer vision and the machine vision. Machine vision, it uses a camera to view an image. But computer vision, it's an algorithm that process, interpret the image before inspecting other components in the system to act upon the data. So that is what the basic difference between the machine vision and the computer vision. So AI's applicability in this machine vision, it relies on affiliated branches like machine vision and deep learning, etc. So the computer ability to simulate the human intelligence is AI, that all we know. So in the machine vision, it requires a computer with the advanced processor, high resolution cameras, large amount of random access memory. So with all these requirements, we need a programming. So for that, AI is used. So AI is a programming that is required for depth perception. So that is what machine vision related with AI. So machine vision is used in various industrial and medical applications. So one such applications was involved with the AI techniques. So that is what the relation between those two. So what are the topics we are going to see today is about the machine vision. What are the components of machine vision? What is the working principle happened with the machine vision and AI? Applications of machine vision and what is the advantages of using it, and then references. So machine vision, as all you know, it is a process of extracting some information from the visual sensors to make system intelligent. So the key points which you consider on this machine vision is automated, its accusation, image analysis, and data. So automated in the sense an automated ultrasonic scanner that is based on the non-contact air-coupled technique is designed and developed. So that is what the automated here is. And image accusation. So this it's a creation of a representation of visual characteristics of an object, such as a physical scene or an interior structure of the object. With that, how the images are accuted. So with that, how the information can be extracted. So that is what the machine vision here is. Analysis and with the data. With the data, how you are going to extract the intelligent information. So that is what the machine vision is. And this involves these are the components: analysis portion, image acquisition, and then integration and application. So these are the three major components with the machine vision. Then components, communication, lightning, lens, sensor, vision processing. So these are the 5 important components that is needed for communicating the machine with the humans. So these are the 5 things that is needed. Okay, I think we might have seen all these components. We'll directly go into AI portion. So why we are going for a vision? So when we consider machine vision, you should have these elements. You should consider about these elements: image acquisition, image pre-processing, feature extraction, decisions, and control. So image acquisition. So generally it is with the camera placed above for the image, we are capturing an image. So that is what the image acquisition is. Image pre-processing. So you are going to process the already available images with the contrast, its blurriness, and its motion. So with that, you are going to process the image. Feature extraction. So we are considering some features with the distance, places. Then we are checking about the components. With that, if you want to take up only the components out of the entire picture, so you are extracting that particular feature alone. So that is feature extraction. Decision. So with the tolerance and identifying a correct position of the particular component, you are extracting that particular component. So that is with precision. Control, so we'll be using some program logical controller or robot controller to identify the extracted feature. So this is what combined together, all together is a machine vision system. So a machine vision system consists of this. So image acquisition, so it transforms a visual image into a digitized form. So visual image to digitized form. That is a image acquisition. Image formation detection. Actually, the image is formed by some elimination from the image object. So the objects can be any hardcore objects. So it is extracted by using a lens, and the photosynthetic detectors detect that information or an object, converts that into some electromagnetic radiation, and that is what the image formation and detection. And vision of the image formation can be of any type. It can be, it depends upon the shape, it can be depends upon the lighting, relative positions, and sensor sensitivity. So image vision, the image formation vision can be any one of these types. And lighting, when you consider on lighting, because lighting is a very important component in the machine vision. So when we consider lighting, these are the various types of lighting available. One is structured lighting, directional backlighting, and then diffuse backlighting, fiber optic LED lighting. So these are the different lightings. So structured lighting here, it represents the process of projections, a known pattern onto a scene. So that is called, it calculates the depth surface information of an object in the scene. That is called as a structured lighting. Directional backlighting, it represents and multiple view display and multi-direction display. So that is what the direction backlighting. And diffuse backlighting, it represents scattered by some particles. So it appears to come from all the directions. So by the diagram itself, you can understand it's a diffuse backlighting. So it is scattered by some particles. It can appear to come from all the directions. So that is called as a diffuse backlighting. Fiber optic or LED ring lights. So that uses an optical fiber as a light pipe, and it transmits the light from a source through a fiber to a remote location. So that is what the fiber optic LED lighting. And other lightings are polarized lighting, direct front lighting, oblique lighting, cross polarization. So these are the other lightings. Polarized lighting means it can be produced from some common physical process that deviate the light beams, including some absorption, refraction, reflection, etc. So that is polarized lighting. And direct front lighting, that represents the lighting that emanates either from the behind the camera or from the camera itself. That is called as a direct front lighting. Oblique lighting, that uses a light source positioned at a low angle. It creates a shadow on the surface of the evidence. So that is called as oblique lighting. Cross polarization. So it's an orthogonal to the polarization. It measures how much leakage was happened between the polarization in a given answer. So that is called as a cross polarization. Remaining lightings are diffuse front lighting, fiber optic near end lighting, dark field illumination. So diffuse front lighting. So it is not harsh and direct. It is softened in some way, and dark field illumination, that is reflected from away from the camera. It is actually informations or lighting informations will be reflected away from the camera. That is dark field illumination. Fiber optic near in lightning. That represents, it's a lighting method for pools and foundations. So we may be seeing some pools and foundations in the park area. So there they will be using this fiber optic linear lighting. So these are the different types of lighting. So lighting plays a major role in the machine vision. And machine formation and detection. So with a light source, it will identify the object, and then it will detect that particular object, and further process will happen with the detection. CCD sensor. So that sensor, it represents a complex electronic component that consists of multiple arrays of light that are sensitive and semiconductor elements. So that will identify the particular object, and it will it will sense that particular object, and multiple arrays of light that is sensitive to the semiconductor element will be identified by using that sensor. And digitization of camera signal, as all we know, analog signals will be converted into digital signals. So analog data will be converted into digital data. And here comes the software question. So software is processing the data. So how do you want to process the data? So usually the software, it allows the image to be processed, analyzed and stored. So it can be done with the steps which we have done with the machine vision system. So we have some 7 to 8 steps is there in the machine vision system. Through that system, we will be going to process, analyze and store the images. Okay, so that can be done by using the software. So we know that we are using some MATLAB for image processing toolboxes, and with that you can pre-process the image, and feature extraction, segmentation can all happen with the processed image. So that is what first is the image pre-processing. So what I want to do with the image? So we'll have to pre-process the image in order to analyze it. So we'll remove the motion blurs and enhance the contrast. So with the images. So these two can be a major feature with the machine vision. And what will be actually the problem? So the human vision, we can see something and machine cannot find the same. So visual tasks can be very difficult for the human. And when you see this picture, so if you want to find out the man in this picture, so we couldn't see by visual, by seeing it, we cannot actually identify where the man is. But the machine has to identify the particular thing. So this can be a difficult task. So what machine has to do is it has to be trained and processed so that the machine can identify the particular human in the particular image. So like that, then it has to be trained. So likewise, if in case of any disasters or something happened with the natural calamities, then how come the machine will identify the object in the tasks, visual tasks? So this will also be a difficult task. So to identify and in that, it has to be trained, and any applications, with some applications it has to be trained. So that is what is done here. So feature extraction and analysis and processing is done for a particular image. So how we are considering? So we'll be considering all the dimensions of the images and features of the images. So with the components, independent components, we'll be extracting the features and it will be processed, and so that we'll be getting a complete information about the image. So the controlled environment will be like this. So with the threshold values, how we are finding out a particular object in the complete image. So the measurements can happen with the images. So the measurements can happen with either 2D imaging or 3D harder. So with the harder images, you can do the measurements. It must have a relationship between the pixels and the world. So in 2D imaging, the image plane and the world plane are in the same correspondence. So we can identify the image plane and the working plane. So that has to be related. So the images should have a relationship between the pixels. So with that you can measure the images. Okay, then comes the machine vision with AI. So here is an important thing. So how does machine vision related to the AI? And here come from this we can study how this machine vision relates with the AI and what are the challenges in that. So machine vision is actually the ability of the computer to see. It employs one or more camera, ADC, that is analog to digital converter, DSP, digital processing, signal processing, and altogether that results in a data, some data to the computer. So it can be a computer or it can be some controller to a machine. So that is altogether is machine vision. So this is similar to the complexity to voice organization. So as all we know the basics of AI. So AI, it involves a development of computer programs that mimic the form of a human intelligence. So what are the common systems or common techniques that is followed in AI is expert system, fuzzy logic, inductive learning, neural networks, genetic algorithms, and these are the important techniques. So we have enough techniques, n number of techniques available, but yeah, what is specified here are the some of the techniques, important techniques that is available with the AI. So first comes a expert system. So expert system actually it is a computer program that uses the AI technologies to simulate the judgment and behavior of the human. So what is the behavior of the human will be identified by an expert system. So that is one expert system. So it consists of two main elements. One is knowledge base. Second one is a method of reasoning about the knowledge it contains. So knowledge base and method of reasoning. So these are the two major elements of the expert system. Next comes the fuzzy logic. So first we will see what is the techniques and then how these techniques are used in the machine vision. So that we will see next. So fuzzy logic. So fuzzy logic actually it is a form of many valued logics in which the truth values of the variables may be either a real number between zeros and ones. So it can be either zeros and ones. So when we see this example, so whether it is hot water, actually the Boolean results will be 0 and 1, and in the fuzzy logic it can be with the variations 0.8, 0.25, and very less is 0.1. So like that it can have some variations in that. So with the fuzzy rules, the knowledge in the system can be expressed qualitatively expressed. So that is what the fuzzy logic is. Inductive learning. Next technique. So inductive learning is actually, it is known as a discovery learning. It is also known as discovery learning. It process where the learners discover rules by observing examples. When we see the example itself, the learners will identify what will be the rules will be. So on the right side of that, it represents the definition, behavior and rules. So we see the image. When we see the image, we can understand what is the what is happening in the image. With that, we ourselves can frame the rules of the image. So what with the knowledge of the image, we can form the rules. So that is what is called as an inductive learning. So discovering rules by observing the examples. So that is called as inductive learning. Then neural networks. So neural networks is actually a series of algorithms that endeavors to recognize underlying relationships in a set of data through process that mimic way the human brain operates. How the human brain operates? The same way we are setting up the data and we are processing the data. So that is what is a human neural networks is. Then comes genetic algorithms. So genetic algorithm actually it is a search heuristic that processes a natural selection that belongs to a large class of evolutionary algorithms. It solves both the constraint and unconstrained optimization problems based on the natural selection. So it mimics a biological evolution. So that is what the genetic algorithm is. So it combines a solution to create a new one and producing a best solution in every generation. So that is what the genetic algorithm is. Swarm intelligence. Swarm intelligence, it's a collective behavior of decentralized self-organized system, natural or artificial, and that can be used for developing some computer algorithms and motion control principles for robotics. So that is a swarm intelligences. And with all these techniques, we have some practical applications of artificial intelligence. How these techniques involved in this applications of machine vision. So that is what you want to see. And these are the practical applications of artificial intelligence and machine vision. One is Pulnix Zcam. Second one is Smart Search. Third one is NeuroChip. Fourth one is Sttp. So these are the four different applications of machine vision. How our AI techniques helps to enhance in this 4 different applications. So first one is a Pulnix Zcam. So it is actually it's a smart camera. It does not need programming. It presents a good and bad parts, and it learns to differentiate the good and bad parts. So that is what the usually the camera will identify the features. So when it takes an image, it will identify, it will extract the features. Here also, it will be extracting the features, and it will produce 74 different outputs from the extracted image. So that is what the advantage of using this Pulnix Zcam. So the features are passed to a neural network which has 74 outputs. So instead of just giving a image, like either a good image or a bad image, that Zcam is trained to produce the products up to 74 classes. So that is what the advantage of using this Pulnix Zcam. That's the first application. Second application is smart search. Actually, the smart search is it's an adaptive learning, adaptive pattern locating software. It is provided by the Corico Imaging. So with the machine vision tools, it was provided. It contains a training wizard. So that is based on the AI, completely AI. So the developer has to provide good and bad examples. And the smart search learns the characteristics of the object automatically. So if an object is given, the characteristics of the object can be identified automatically. So that is called as a smart search. Then next one is a NeuroChip Compact. So in NeuroChip Compact, it is actually a smart camera. This is also a smart camera that can be programmed using a mouse. So the system contains a NeuroChip package. So that is able to compute the number of object features from the regions of interest in an image. So these features can be classified, and it determines the type of the region being inspected. So that is called as a NeuroChip Compact. We will see one video out of that NeuroChip Compact, so that we will get a better idea about that. Sci-Tech iBot. So the Sci-Tech iBot is actually a name of a robot family that is developed by UWA. So that is iBot. So the Sci-Tech iBot, it learns part, form and features. It combines the physiologic and neural networks both, and that is known as a NeuroRAM. And iBot, it is available in two formats. One is Shape iBot, second one is Spectrum iBot. Shape iBot, it recognizes the shape of the objects. Spectrum iBot, it learns the color of the objects. So that is what the Sci-Tech iBot is. So it uses the fuzzy logic and neural networks so that it can get a shape of the objects and color of the objects. So that is what the next applications. And the last application is ILIB software. So ILIB stands for Intelligent Library Management Software. Okay, Intelligent Library Management Software. That actually it is a library for managing books and images. Intelligent Library. So it will manage the books and images of the software. So actually it incorporates many techniques like fuzzy logic, neural networks, pattern recognition, so like that. It involves many AI techniques, and this is provided by a multi-layer perceptron neural network. So with many configurable parameters. So this library contains a pattern recognition techniques also. So it can be easily identified with the help of a K nearest neighbors can be identified, and it is also known as ANOVA. So ANOVA is actually the analysis of variance software. It's a collection of statistical models, and it is associated estimation procedures can be easily identified, and it is used to analyze differences among the group of people in the sample. So that is what is done with the ANOVA. So these are the applications, and this is the screenshot of that. So advanced searches, the title with the author and the subject can be given, and it can be searched according to the articles or books or visual material, whichever thesis work or material that you provided, that can be easily identified by using this. This is a library software. So this is also one of the applications of machine vision with AI. So these are the various applications, and the AI techniques are involved in these applications. Okay. Then machine vision and automation. So actually, we are using a camera to inspect the parts of the machine. So it guides a robot and it controls the automated equipment. So it uses a CAM, that is computer assisted manufacturing system. So it ensures the quality in the manufacturing process. The quality based upon the color, placement, or all the components, whether all the components are placed according to the model, and what is the dimensions used, and what about the alignment. So entire thing can be done, ensure the quality of the manufacturing process. So that is a machine vision's role in automation process. Okay, so the the AI smart camera, which I've told you about. So this is a video on that. So future vision, AI vision of AI, which machine vision is this.
Can you tell if your cows are feeling okay? If Oh, can you tell if your cows are feeling okay? If your cows are uncomfortable, they might not produce enough milk. A comfortable environment with the right temperature and humidity will keep cows healthy and happy, maximizing milk production. When it gets too hot, AI machine vision can pinpoint the position of each cow's udders and then turn on the sprinkler to cool them down. This way, all your cows can stay healthy and produce plenty of milk. The same principle can be applied to laying hens. High-quality eggs can sell at a better price, but how do you separate all the high-quality eggs from the rest? AI machine vision can quickly check the quality of your eggs and sort them according to your quality standard. Is your farm constantly growing? How do you remove weeds without hurting your crops? AI machine vision can detect and spray pesticides on weeds directly without affecting nearby crops. This helps you protect your crops and keep yields up. Does your factory operator comply with standard workplace safety procedures? AI machine vision can identify when employees are not wearing the appropriate safety equipment to prevent workplace accidents and keep employees safe. AI machine vision can even detect hazardous chemical spills to guarantee the safety of the workplace environment. Does your production line have defects that are hard to detect using traditional AOI? AI machine vision can find defects faster than professional QC staff through exceptional accuracy and efficiency. These types of AI machine vision applications require the development of AI algorithms for deep learning. The software experts who develop AI algorithms need a smart, reliable platform for executing AI model inferencing. Neon AI smart cameras provide highly integrated, worry-free reliability and faster deployment. Neon, the future of AI machine vision.
AD-Link, leading edge computing.
So that is what smart camera, which is used for searching. And next comes the challenges. So these are the techniques and the neuro check. So how that happens, we have seen, definitely we have seen. And these are the challenges. So challenges is very important topic of machine vision and AI. So the challenges here, what are the challenges related to the AI and machine learning is, sorry, AI with the machine vision is, first one is a random box, random object picking, and random box depalletizing. So actually, the workplaces may vary, and there is no match for the schema systems very clear with the robots. So that is what actually the box depalletizing is a boundaries between the boxes that are difficult to judge with the intelligent machines. So the box's boundaries cannot be easily identified with the machines, intelligent machine vision system. So that is what the basic challenge. So picking up an object randomly is a problem, is the biggest task, and identifying the boundaries between the boxes. So that is also with the help of the robot, if it wants to identify a particular boundaries, that is also a biggest task with the intelligent machine vision system. So that is one challenge. Then, when you say the other challenge, it is difficult to detect and defect and flaw detection. So flaw detection, since it's a random access, so the flaw detection and identifying motion detection, that is also the biggest task, and the mobility in the computer vision. So that is the biggest task. And imaging inspection involving in the reflection and the shiny metal parts. So the inspecting the shiny metal parts will also be a biggest task with the machine vision. High-speed inspection. The high-speed inspection, any machine vision system that must run at rates. That is, it should be running above 30 fps is considered high-speed applications. But it depends upon the size of the product speed. So it can be up to 50 parts per second, and that can be incredible. So depending upon the high speed, the machine has to be with the running weights. The machine has to be identified with the application. So that is also a biggest task. Then vision guided robots. So actually, it is a collective terms of machine vision and image processing systems. It is used for position detection and inspection with the industrial robots. So accurate movement to identify the target position. So that is the task, biggest task. So that is also a challenge. So vision guided robots and multispectral imaging. So actually, it captures the image data within a specific wavelength. So it ranges across the electromagnetic spectrum. So identifying the spectral images, multispectral images is a task. Then polarization. So the property that is applied to a transverse waves. So that specifies a geometrical orientation of the oscillations. So identifying a property by a geometrical orientation will also be a biggest task. Embedded vision. So it's an integration of camera and processing units. So the vision system should consist of a camera and a PC, and both will be very expensive. So building up with these embedded visions will also be a challenge. So these are the challenges with related to the machine vision. And one article that was published in 2018 that considers the challenges, one biggest challenge with society. So machine vision combination with the AI that solves the biggest and toughest society problem, society and the business challenges. In 2018, it was an article in the Intel IT peer network. And what it means is it combines techniques of both the AI and machine vision to help to solve the societal problem. So what was the problem actually is so missing of children. So missing of children can be easily identified by using this combination, machine vision and the AI combination. So actually the human visual perception is an important task. So humans have limited capacity to evaluate compared to the machines. So how this can be solved? So this was solved. So the machine vision can solve one of the biggest society problem. So new images of the children, if the missing children has to be identified, they have to be given with the new images of the children from the identified content, and that has to be analyzed through a machine learning, and the features has to be extracted, calculated, and numerical representations of the objects has to be done, and many algorithms are involved in representing that objects. AI trained algorithm is used and is compared with the digital representation of a new image, and the databases has to be used with the already available missing children list. So if there is a match found, then it will be identified as a victim. So like that, the AI algorithm is used in the societal problem. So this is what the problem. What software they have used for that applications is, so the tackling machine vision applications, they have used MEM-SQL. So MEM-SQL actually it is a real-time data warehousing, and it is a collaborator. It will identify the objects. It will identify the objects by real-time image recognition. So it uses a dot product, MEM-SQL dot product. So it enables a vector comparisons for real-time image recognition. It calculates the feature vectors with a computation workload and processor-based infrastructure. So actually, this MEM-SQL is a single-store modern relational database for cloud. So it's a distributed and relational SQL DBMS that features the ANSI SQL support for speed in data in digest and transaction processing and query processing. So it can run in various environments like Linux environment, and it identifies the images with the dot product. It calculates the feature vectors by using the dot product. So this is what the technique that is used in that particular project, and they have identified success in the maintaining the social challenges. So this is what one application. So what did they do first is they will train the AI deep learning system with the known inputs, and then once the data analytics program is solved, then that can be implemented by using any one of the machine vision technology with the help of the MEM-SQL. That's a single store modern relationship database. So from the cloud. So they have used the MEM-SQL, and the feature vectors are calculated with the deep learning algorithm. So this is what the technique they are involved in that problem, and they have solved it. So to overcome one of the challenges, one biggest advantages of using that, overcoming the lot of challenges, is self-driving car. So now we have seen so many self-driving cars, unmanned cars, identifying the vision, that is the movement of the core vehicles, and the parking slot will be identified easily. with the sensors, and it will park according to it. So like that, that is the one biggest self-driving cars is one overcoming challenges with the or existing challenge. And the survey on the state of the AI based machine vision is there are many issues in current inspection method. So what are the major causes with the percentages? So since incidents either good part being marked as defective, since being a good part that is also marked as defective part, and this is also happening, that's false is also happening, and that is what the biggest percentage, that is what's 56% of that is happening as a marking good one as a bad one. So that is what is happening. Secondly, inability to deal with the complex inspections. So that is 50% of that is happening. And inability to deal with the variations. What is inspected, if there is any variations. To identify the variations is 42% we are still in lagging. And labor cost is also too high to combine with the AI machine vision. So the labor cost is 41% of that is too high. And maintenance cost 13% expensive. So these are the major issues with the current inspection methods. So this is what a survey. So the key finding is that, so in the overall opinion, so 15% is very high, 39% is high with the effectiveness of AI opinion, 28% is moderate, 4% is low, and it is not effective is 2%, and 12% it is not known. So altogether, when we say the overall opinion of the effectiveness of AI, 39% is it is high. So still it has to improve with the effectiveness of AI with machine vision. So the benefits of machine vision with applications is higher performance and quality inspection, and it increased productivity with the repetitive tasks, production flexibility, less machine downtime and setup time, equipment cost is very less, production cost is less, and inventory control and the reduced floor space. So these are the benefits of machine vision with technologies. And what is a machine vision system altogether? So machine vision system, as we know, so it is used with a one technology. So one application used here is a AI. So AI is used in vision system for continuous improvement in the recognition applications. So it will identify any of the incorrect predictions, and it is associated, if it is associated with the data, that will be easily identified with the vision system. So that is one advantage. And the types of machine vision systems means 1D, 2D, and 3D. So 1D vision, so it analyzes signal one line at a time. 2D means it will capture an object and uses a two-dimensional mapping. And 3D vision system, it includes multiple cameras, one or more laser displacement sensors are used for identifying. So these are the three different types of machine vision. The use of AI in machine vision applications is, one is IIoT, that is industrial IoT. That is, there is a raise in the IIoT. So with the machine vision only, there is a raise in the industrial IoT. So it refers to the interconnected sensors and instruments and other devices. So the networked together, the sensors and other instruments and devices are networked together, which come with computers, industrial applications, that includes manufacturing and energy management. So that is what is industrial IoT is. So with the rise of the AI and vision, industrial IoT will also get increased in their features. So this is what one vision used. Second one is ability to recognize the object. So defects can be easily identified, and you can improve the accuracy of the vision system with the help of AI and machine vision. So this is second advantage. Third one is for inspection applications. For instance, accuracy translates directly into productivity and profitability. So that is one biggest for inspecting, for identifying the defects. If the accuracy translates into productivity, then that is an advantage for using that. So in that way, this is also AI with machine vision is useful. And these are all the specific goals with the AI machine vision. So AI machine vision helps to meet the specific goals. So the goals here represents are quality, productivity, flexibility, reduction cost, inventory control, flow rate, equipment cost. These are the goals. And how come the machine vision solves these problems? By regular inspection, by measurement, and adding some vision to the machine to improve the performance, and one vision system with many people and detecting the flaws. So these are all the applications. So for individual goals. So with the regular goals, with the identified goals, if we have a proper application, so then we can achieve the machine vision with the AI. Okay. So machine vision, how AI brings value to industries. So in case of industry, because we are saying about industry 4.0, we are learning about that. So how come this AI brings values to the industry? So enterprises are mostly using the AI applications. In 1 in 10 enterprises, they are using 10 applications, different applications or techniques that is used in the industry. So AI has become a vital role augmenting human abilities. So machine vision. So to identify the objects, analyze the objects in the with the activities, that is the biggest task. So your machine vision with the help of AI, it works effectively, assisting them to identify a particular object, and repetitive with the repetitive tasks, machines will also be trained to capture the correct object. So if something can be captured on an image or a video, chances of the machines can be trained so that you can analyze and identify the exact thing. So this is what is happening with the machine vision and AI. So manufacturing industry also, so they are there. Optimized AI algorithms are used. So they analyze the real time and they notify other systems immediately when there is a fault or any irregularities happen. And how we can make the machine vision work smarter with AI. So these are the questions. Are there any specific machine vision applications where AI has the biggest impact? Yes, we have. So what is that? So we have a traditional machine vision, automated optical inspection works. So this is a tool so that works well on objects so that you can identify a biggest impact on AI. So AI powered vision detection, it provides a speed, accuracy and repeatability at low cost. So this can happen with the machine vision application. So this is one. And the second question is, what do you see as the keys to successfully leveraging the AI as a part of machine vision application? So there are three keys to successfully leveraging AI as a part of the machine vision application. One is developing an efficient AI data acquisition and management strategy. Second one, robust process to deploy and manage the AI in production. Third one, different stakeholders are identified and ensure the organization is ready to adapt to our AI technology. So these are the three key issues so that it will be successful with the AI and machine vision applications. And what are the challenges do manufacturers need to overcome? So top challenges is small data. Actually, the small data here it represents, it is not actually the small. Small here that represents consumers in internet companies must have a biggest data from more users to train the AI system. So AI models they developed for big data problem, and they do not work on a small data settings. So that is one challenge. Second one, ambiguous defect requirements. So identifying a defect can be a subjective matter, and it is a common for two inspectors. One is working on scratch is a problematic, and the same scratch is small enough to be ignored. So that is also a biggest challenge. Changing environments and requirements. When changes happens with the internal or external environment, it occurs as lighting, material, performance in that case. So manufacturers regularly change their requirements that alter the product appearances. So that is also the problem. Compounding complexities. Every AI project is complex and of itself. When trying to scale a project to many stations, lines, and factories, only compound on themselves. So that will also be a biggest challenge. So how do you see the use and effectiveness of AI continuing to evolve with the machine vision space? So in early stages, it is adopted to a manufacturing, and many projects they are stuck with the challenges, basic challenges, lack of data, and basic challenges. And now it is overcoming those challenges with the help of a combination of different techniques, different upcoming techniques of AI. So this can be the usage and the effectiveness of AI can be improved. And these are some of the related research papers. So that was happening on the machine vision with AI. So research on intelligent recognition of training images based on the machine vision. So it compares the various weighted average fusion methods and fusion of results of the objective and the subjective evaluation are compared, and the wavelet transform is used, and so that how the machine vision AI field of image processing is helpful to the identifying the image. So in that, train the image. So in that case, this search was happened. And the second is pattern design of knit and the pearl based on the CAD system of automatic knitting machine based on the computer vision integration. So the automatic knitting machine that is based upon the computer vision integration is studied here, and machine vision technologies are combined to achieve the automatic analysis. So they validated the effectiveness of the analysis. And the next one is machine vision being based on the localization of the intelligent vehicle. Actually, the host vehicle parameters of position and direction are accurate to the lane parameters. So in this algorithm, they have used a lane parameters using a half transformation, and the experiments are analyzed with a good adaptability and illumination condition changes, and can satisfy many system requests on the certain extent. So this is what is explained with the machine vision based localization of intelligent vehicle. So these are some of the related researches, and these are all the references with machine vision. I have more videos, but right now I couldn't. I'm not able to share everything. So I think with this, I come to an end of the session. So I thank Arun sir and our HOD, EC HOD ma'am, Panamera Institute of Technology, for giving me this opportunity to deliver a session. Hope all the participants have gained some knowledge on machine vision in AI. So thank you participants and the entire team for organizing such a wonderful FTP. So the title itself, the title and the theme itself is different. It's unique, and it looks good. So we have gained some knowledge about the machine vision. So thank you for patient listening. Thank you all for listening. Thank you, sir.
Thank you, ma'am. Thank you for your valuable presence. It's
Thank
indeed
you,
a
sir.
great privilege to host you at our institution. You have been always a constant support with us. Anytime we give you any topic, you are always ready to handle the session. On behalf of Panimalar Institute of Technology, Department of Electronics and Communication Engineering Department, it's indeed my great privilege to thank you for your presence. Dear participants, if you have any queries, you can post it in the chat box. And meanwhile, I will, as a token of love, I'm just sharing a e-memento. Please do accept it, ma'am.
Oh, thank you so much, sir.
Thank you, ma'am. Thank you.
Thank you, sir.
Dear participants, if you have any queries, please do post it in the chat box.
I think it is a lunch break.
Yeah.
Okay, sir.
Thank you, ma'am. Thank you for your
Thank you, sir.
valuable
Thank you so
contribution.
much, sir.
Thank you, ma'am. Selvarani ma'am, can you post the feedback link in the chat box? I request all the participants to fill the feedback before you leave the meeting. Thank you once again on behalf of Panimalar Institute of Technology for joining with us. We will have the day 3 session starting tomorrow sharply by 10 a.m. I request all the participants to join tomorrow's session by 10 a.m. The feedback link will be
1 minute,
shared.
sir. 1 minute, sir.
Sure, ma'am.
1
Sure.
minute, sir. I will share, sir.
Okay.
Uh,
The feedback link is posted in the chat box. Please do fill it. Thank you once again on behalf of Panimala Institute of Technology for joining. We will have the next session by 10 a.m. Please do tomorrow 10 a.m. Please do join. I request all the participants to fill the feedback form before you leave the meeting. Dear participants, once you are done with feedback form, you can leave the meeting. Thank you once again on behalf of Panimala Institute of Technology for joining with us.